we're going to find the area of the shaded region. So what we can see looking at this picture, we have a function bounding on the top. That would be 1/2 secant squared t. You see it right here. And then we have a function bounding on the bottom. That is -4 sine squared of t. One thing we might notice here is that both of our functions are even and both of our functions are symmetric with respect to the y-axis. So we can just look at the right half and double our integral value. And to reiterate what I'm saying, instead of having our interval go from pi over 3 negative to positive pi over 3, we can eliminate the left half and just say we're going to integrate from 0 to pi over 3 and double this. So let's look at setting up and calculating the area between these two curves. So I'm going to set this up, my integral, and I'm going to say we double it. We're going to go from 0 to positive pi over 3. My function on top is 1/2 secant squared t minus my function on the bottom, -4 times sine squared t, integrating with respect to t. Okay, so let's work through this problem. I'm going to separate these two integrals. I don't need to write a anymore. So I'm going to pull the 1/2 out, and 2 times 1/2 gives me 1. So I have the integral from 0 to pi over 3 of secant squared t dt minus, and minus -4, that's going to become a plus. 4 times 2, I will have 8, integral from 0 to pi over 3 of sine squared t dt. All right, so integrating secant squared, that should be pretty easy for us. The integral of secant squared is tangent, so I've got tangent t evaluated from pi over 3 to 0, plus 8. Now, in order to evaluate sine squared, we're going to need to use a double angle substitution. And so sine squared, we know, is equal to 1/2 times 1 minus the cosine of 2t. If I pull that 1/2 out, and I'll just evaluate all of this at the end. So I'm just going to rewrite it. Pull the 1/2 out, I have plus 4. The integral from 0 to pi over 3, I'm noticing I have a little 2 right there. Let me change that. Can't just change a number in the middle of a problem. Of 1 minus the cosine of 2t dt. So this, continuing, I've got tangent of t, pi over 3 to 0, plus 4. I'm going to integrate 1, that would become t. Integrating cosine, that would be sine. So I've got negative sine 2t, and because there's a 2 in there, we divide by 2. That piece will need to be evaluated from pi over 3 to 0. So really, I'm integrating tangent of t plus 4t. Distributing that 4, I get minus 2 sine of 2t from pi over 3 to 0. So I'll plug in pi over 3. If I evaluate my function here with my pi over 3, I've got tangent of pi over 3 plus 4 times pi over 3 minus 2 times the sine of 2 times pi over 3. So that's my first piece, minus whatever value I get when I plug in 0. So I would have minus tangent of 0 plus 4 times 0 minus 2 times the sine of 2 times 0. So evaluating all of these terms here, tangent of pi over 3 is square root of 3. I've got plus 4 pi over 3 minus 2 sine at 2 pi over 3, or 120 degrees, is root 3 over 2. And then we have minus tangent of 0 is 0, 4 times 0 is 0, and 2 sine of 0 is 0. So this guy just goes to 0. And these 2's cancel out. So I have square root of 3 plus 4 pi over 3 minus square root of 3. Square root of 3's are gone. And my answer is 4 pi over 3.